all these things in streaming. So even if you are at home, I would have to give you the address that I don't even check now. So we have another of the features of OMS is the use of time series. So what we are doing here, the usual operation, okay, that's important. So we have a few components interacting in this in this sim file, which start to be very complex. And the idea is that we have this this first component that get start and end, and then the model. In the as we will see here, the way to manage the time is a little different from the other ones, because maybe you can read here is while reader done. What we will be doing is reading a file, going away to run the things until the file ends. When the file ends, also the simulation finished. Then we have three output here. Reader done is a variable that is used for the iterations that control all the stuff. And then we have other two variables. One is called current, and the other one data. The current time is given to an iterator, which is essentially this scheme here, the first and this last on the right components, more or less is the scheme that we are already seeing. But here we introduced the other components, which is called kriging, but it's not actually doing kriging here, and is writing the data. And we have another input here to this component. So you see that with components we start to build some complex network of the execution, and obviously you will see in the next days very much complex executions, really huge programs working together in this way. So let's go. You can go with me and execute your stuff in case. But let's see the sim file. Let's read the sim file together. This is the class. Okay. Okay, this is the simulation file. So you see here the model, the iterator contains the while reader is done, which is the usual controller of the Boolean controller. There is a reader start. The date is 1/10/2001, meaning 1. Actually, 10 is 1st of November, according to.
No, this time is October.
Oh,
when you use the Java stuff.
Okay, when we use Marco check before when first this is October. He said as is written, but the other one when we use the Java stuff, the numbering of the months start from 0. So my 9th is actually October.
But the day from 1.
Yeah. So this is the initial date. This is the final date. There is the Java calendar. Okay, we choose the day of the year. This util is useful also because sometimes you have years that has some one day is more than the others. So this helps you to manage properly the date. The reader amount increase one step each time, and this is more or less what we already have seen before in other examples. How many components do we have? We have map reader, which is something that reads something else. Then we see what it reads, but we don't have in parameters any file in input, so we will see then what it's doing. We have a time iteration reader, a time series iteration writer. The reader read and the writer writes. Then there is a component which is called kriging. I don't know actually what is inside in the kriging components, but I don't think it is actually a kriging. It's just it was given this name, but it doesn't do effectively any complicated operation. We will say in 2 days what a kriging is for, especially for who do not know what it is. And then the connection. So we know that reader data, which is this component here, has a component, has a data set which is called data. In fact, we could see here, unif amount and reader data. The reader data here is in output, but the schema is essentially the one we see above. The reader data output go in input to the kriging in data. Here the name change. For some reason, maybe it's useful to know if one is an out date or a data in input or in output. So in some of our programmers do put out date when a data is in output and in date when it is in input. So current goes to current in writer. Out data goes in data of the writers, and the map of the map reader go to the kriging map. There is not much more to say here, and when I execute, here I import another function, which another library, which is glob. Glob is used to put wildcards when doing asking for directories. So here I want to glob looks for all the files that start as ex19 in the directory. Otherwise, I have 20 files and the information is not useful. And actually, I have one simulation which has simulation file, which is simulation x19 time iterations pass. And so what we do is just to execute it. Yeah, we don't have, we can give a look more, maybe more close to the example. Here in data, let's see. We don't have any data for that file here. So essentially what it does is nothing except for reading the data and putting out this information, and the simulation goes. I put on schedule that we did the other two small simulation, but I think you have now all the tools. The concept for looking for our cells is using a couple of different strategies for output. Maybe we will see in detail in the next days, otherwise we run out of time today. Instead, what we will see is the water tank example. That now is it okay. What is the water tank example? Let me kill a little bit here of simulations and data to clean. Okay. Water tank example is taken from this manuscript here that you see, which is a tank, a simple tank which has a large input, a small output, a large volume. You put water inside the tank between on the top. You work it out from the bottom. And in this paper is particularly simple. You have in your material that I put for the school, and here you have all the theory and the work. But the important thing is that at the end, for us, we don't have to care much to the details, but we are able to calculate the velocity, the quantity of the velocity of water, the times of okay. We have these equations here that we have to solve, which is the H over the T. H is the quota of the water is minus 2H0, where H0 is the initial conditions on the level of water, and a formula that depends on this tau d, where tau d is given down here somewhere. Now I don't see it. Okay, it is here. Equation 4 is given, and this tau d is given in function of the initial level, the acceleration of gravity, the initial sections, and the section, the actual section at time t. So the information we have to bring home here is that we know how the physics of this tank works, and now we want to implement a model of these things. The model is implemented actually in here. As you see, I could repeat most of the information in the Jupyter file, and one new thing is here that you see an equation. The equation is written in LaTeX. Who of you know what LaTeX is? Nobody?
I know,
yeah. LaTeX is a way to is the best way to write formulas in academia, at least, or to write papers that contains formulas. You can do in Word, but you can use a card for entering in a room by breaking with the card the door, and that's more or less the same thing. I am exaggerating, obviously, but so you can misuse a tool for doing things. Here, LaTeX is a tool that was developed by Donald Knuth, which is worth to mention because Donald Knuth was one of the people important, the researchers important in the informatics. He did this Bible of informatics, which is called the heart of computer science, the heart of computing. Now I don't remember even the title. But his third book is one of the best-selling book ever, and is really at the fundament of doing algorithms. And so any programmer should know how should knows about at least one of his books. For doing these books, he didn't find any way to write the formulas. So he did a typesetting system that we call TeX. Is written sometimes like it looks like with a capital X, but is actually meaning the key Greek letter. This type of format is complicated. It took several years for him to do the systems, and then he wrote all these books, this Bible with TeX. Leslie Lamport later on simplified this structure, introducing some macro which is called LaTeX, like Leslie Lamport TeX. And most of us use actually LaTeX, not the pure TeX, to write formulas. So this is at the end, this is a formula written in the LaTeX. You see here there are two type of. This is $$ means a formula that is big inside the code, and this is a small here LaTeX information, which is just a single variable, and here is how it is rendered the formula. And you have inside this system you have a large control on the character that you write, especially in all the formula that you see that I write everything in this system actually. Now after these diversions, let's go to the sim file. This was made by a school taking actually 2 years ago in July, when we have the summer school on OMS here, and Olaf David was here inside other friends that works on OMS 3. The simulation name here is water tank. We have the code inside here, so there is a build also of the code. And what are our components? We have 3 components. We have water tank climate, water tank output, and water tank tank. I already showed those this morning. It was not randomly chosen, but it was because I knew that was presenting to you. Actually, what the climate does is it read some inputs data. What the output does is read the output data, and what the tank does is just implementing the formulas. This is at a certain point one nice things, because here we separate the input, the output, and the simulation things. In our geotop model, we have most of the code is treating input output. The actual effective code that does simulations is a small part of it. But obviously, this is in these 100 of lines or things that one have to look. One who knows a little bit how was written the code can go more or less easily. And I look into some people that way is working with the source code. and to the part of the code when there are modifications to do. Here, the three things are separated in components. Today, we are writing outputs or reading inputs in a way. Tomorrow, we want to read and write in different way. We don't have to get through to throw away also the baby, as I said this morning, which is the algorithms. We take the algorithms and change the components that do the reading and the writing, and we read and write whatever we want to read and write. So the climate has a field which is the rain rate. So meaning that the reader read a rain rate and pass it to the tank. In the tank, there are a certain number of variables: volume, depth, velocity, discharge. And this goes to the input of the component which is called out. Fortunately or unfortunately, I don't know, but the field of the out component have the same name: volume, depth, velocity, and Q-out. So we learned before that we actually can avoid to put this volume, depth, velocity, and Q-out because they take the same name. So we have further some parameters in meters and in second, which is the one that you see here. We have a further parameter here that the output file, in this case, has a name, and the name is output.csv. Here I left this part here but we will not use it. In OMS, there is a part of the code which is dedicated to produce results of making graphics or things like that. This is very useful sometimes, but we will not use it here, and it actually doesn't work inside our system because we mediate the use with the Python notebooks. So this thing is not executable inside the Python notebooks because it would be really a magic if it works, because it has to open windows doing something that has to do in different parts. So at the end, our code will be just, our simulation file will be including just these things and not the plotting result. Plotting inside OMS is possible. It also has some nice results. Sometimes can be useful. But let's say that in an environment like Jupyter Lab or Jupyter, there are so many people working that they could produce an astonishing bunch of routines to present results. So they did a good job, and we cannot keep the pace with them. Assuming that we want to develop the better way of visualizing our data, we cannot keep the pace with such a big community as the one that is behind the Jupyter Lab. So we choose to use Jupyter Lab to visualize the things. With respect to the other components that we executed before of this one, there is also a novelty, which is if we go here, if we go water tank, we see that the directory data finally is not empty. It's not empty because we have a climate CSV, which actually we are not using. And we have parameters CSV and rain data CSV. I think we are not using not even parameter CSView. No, we don't use even parameter CSView. We are just using this data set. I can click. It's supposed to be a comma separated value file. The Jupyter has a way to see the Jupyter, the CSV file. Unfortunately, it happens that it looks very strange. If we go outside our program and look at what it actually contains, we will see that it has the first line here are a header for the data, which is a special format, which is the OMS CSV file, in which you can recognize that there are some annotation here that make explicit what is inside, make the file completely explained, but it's not the usual file. Anyway, we will read this rain data with Python. And the way to do it is we go to the water tank example. So more or less, this is a scheme that we promote also for the next days. We will have simulations. First of doing simulations, we have some inputs data. And the thing that I told to my young colleagues is students actually say, yeah, you have to do a simulation, but first of doing a simulation, you have to look at the data sets. We have this feel to rush to go to a solution. So sometimes the first example on which we built our example as clean data, we go. Then the next time we get data somewhere from the other, we say to the other, it should be a file that is done this way, so and so is a CSV file with this header. You have to specify these things. Then we don't look at the data. We just plug the data inside our model. We run the model. We see that nothing is coming out. That is anyway a fortunate case, because the worst case is that when we run the data, we have some result, we look at the result, and then we start to not understand what is going on. But probably one reason is the data were formatted in the proper way, but probably was not correct. So the first thing we have to do is to look at the data. And we actually did it here. Okay, here I just the usual notebook that run the things and do the simulations. But if you open, okay, one thing that I do here is better that I just kill all the simulations, because I have so many kernels running in the background that you say too many files open. There is a limit of numbers of simulation, but because I just closed the notebooks, but at the same time I didn't care that actually the kernels were running. So I kill it here. Okay. Now I kill also the Jupyter Lab and start again. Yes, let me change, check one thing more, which is okay, I don't. Hopefully this now is going to work. Let's see. Okay. This is the usual command, but I invite you to give the command with me. So to open your Jupyter. Open a new Windows, new file, new notebook. Okay, if we want to. Okay, we can do. Okay, we do the import. Let's rename this one here, which is renamed like afternoon task. From the way you are, I am hearing you. You are very tired at this moment. But let's go. Maybe I can illustrate these things now, and tomorrow morning maybe we can do some the output file at the very beginning when your mind will be fresh, and my mind will be fresh too. Otherwise, so this is the usual import. If you are able to keep pace with me, please do. We'll look at the directory. I go a directory back because I go a directory back because I have my data, the data I want to visualize in the data directory, and I do this thing. I could, inside Python, I could do even a more interesting thing, which is connecting two notebooks to the same, to actually the same kernel. So when I am executing one notebook, actually I'm producing data inside the other kernel. So the thing, we are doing, I can do the things in two different parts, and here I use a strange structure in Python to do one thing. It was just illustrating one way of operate. Usually here I open a CSV file as in the name of my file. It is a new operation that you didn't see before. And then I select, I give to the variable head. Okay, this is a very complex way to do the things, but just to illustrate some also Python structure. Here I have two square parentheses. The square parentheses indicates usually an array. So what is inside here is an array. I say next my file for x in range 5. Range 5 produce an iterator from 0 to 4, actually numbers, 5 numbers, but enumerated from 0 to 4, and say for x in that goes from 0 to 4. This is what say this one. Next my file is read one line and read the next line and present the results. So I can assess if I here on the left what I did on the left was I assess every one, not each one. I assess the data in the variable head that I get inside here. I can assess actually all together, as you can see all together. Okay, this is a vector whose elements are singularly the lines of my file. Why I read five lines? Because I knew in advance that there was 5 lines of header, no things that are no data, but just information about data. For knowing that, there is no other way with this format to go open the file, look at the file, count the name of the. Actually, that is not really true. We can build a program that interprets the signs that are here inside and read properly the data set. But if you don't know what this AT means, and this means that there is a table which is called raining data. This has to do with other things, in particular with the header, the specific header of the data, and so. Here, okay, I did. I did nothing particular. I was in vain when I did this. I was in vain in the mood to do some to play around with Python. Actually, I took the last things of here and I split in this part, which is unit and millimeter hour. But it's not really important. What is really important is the command that comes later on, which is this one, which is introduce a new thing. Let's say that what I did before was just to understand that to skip, to understand the first lines and know what there is in the first line, because I know that in the first line there are no data. And the data are after line 4, which is actually the 5th line of our data, because we have line 0, line 1, line 2, line 3, line 4. And I use here, and I use here a new command, which is pd. And you see here that I imported a thing which is called pandas. Pandas in Python are a very powerful library, which is going to made for treating tabular data. You have like a spreadsheet sheet is the fundamental element of pandas. You can do a lot of operations on spread, and this and this library is very powerful. So we have this panda libraries is all contained this PD, and after we have a reader here of pandas, which is a reader of a CSV file. The CSV file is rain data CSV, is a comma separated value. It has a separator comma. I skip the first 5 lines because I already verified here up there that there are 5 header lines. Just opening the data, I can open even outside this. If I go in my things here, I go to workspace, winter school, water tank examples, data, and my data is rain data. If I give a, you know, here it is, the data. Very trivial. But I have 1, 2, 3, 4, 5. Yeah. Who is in streaming is not seeing that, but you know, it doesn't matter for the. So we have 5 lines, and there is another command that has to do with the memory. So I am reading in these things, and here I can see the first 5 elements. Okay, here you already see the result, but you say this is the index from 0, etc. Then you have not the numbers. Why we have not the numbers? Because if you look at the original file, we have a comma at the beginning of each lines, so the first data is not appearing. We can open it here for clarification. We can go here, go to water tank example, going to data, going to rain data CSV. You see, now you don't see actually here because say, or actually you see here because you see the first column is completely empty. Here.
You can right click and open the editor.
Sorry?
You can right click and open the editor. Over in data.
Where?
Go over in data on the left panel. Left.
Okay.
Right click, open with. You can do with editor.
Okay.
And I guess it opens inside with the
Okay, okay. Good. Thank you for the suggestion. You see here, much better here. This is null data. So you don't see how the first, I have a column here that I have then to take away. Here we can skip. Is not used used for a certain task, and then I have this command is a command in pandas that is used to eliminate the first column. Okay, and finally I show here the data that I show in this way, which is maybe not the better way to do it. There are some commands, however, that I want you to see. Is the we import that the library for drawing, which is matplotlib, and in particular one view of matplotlib, which is pyplot. Pyplot is trying to reproduce the way that graphics work in MATLAB. So I import this library here, and there is commands in the Jupyter. There are commands that start with the percent sign, and this means is called a magic. You do something behind the scene to do something. In particular, in this case, it says when you produce a figure, please produce and show it and show it inside the notebook. And then we have a little bit here of examples, which is also reproduced on the right, which is I can call a method on data, which is plot. Do a plot. In particular, I want to call a bar plot. I put the axis here rotated by 45 degrees. And you see here the abscissas is all rotated. The fig size is 12, 14, means essentially that the base is 3 times the height. I put a title, which is rainfall example for the water tank. And then I issue a command that also really plot the things. We will repeat several times in this week these things. And what I obviously obtain is this in this graph here. Let's see even more larger. And this is all the results. This is a pretty rude, pretty rough model. But here I generated an input of the a representation of the input file. You see, we have zero precipitation for 18 minutes, I guess. And then we have rainfall precipitation from minus 19 to minus to minutes 37, and then we have the output. And and then we have again 0. So this is the input. And what our model does is, if we go, when we execute it, is just it read all the data in the input, and then it executes the program. It gives an output, and the output goes until time 57. So here to say that we have a way, one of the way to do interaction inside OMS is just providing a file with the data, and as long as there are data in the input file, the simulation also will give outputs. I believe that now we are all tired, so we'll stop here for the things, and tomorrow we start from this point, and then we will go home. If you agree. Everybody agree? Anybody want to see more? Okay. I hope that for the day we did enough, and otherwise we can do more things in the tomorrow. So thank you very much for being here.